By the summer of 1969, outside Cumberland, Ohio, a machine the height of a 10-story building swung a bucket larger than most homes. Officially designated the Bucyrus Erie 4250W, trade literature simply called it Big Musky. Its bucket alone carried 220 cubic yards of earth, 325 tons per pass, driven by electric motors fed through a trailing cable thicker than a man's leg. Construction Equipment magazine that year described it as the most powerful single-bucket excavator ever constructed. The scale was intoxicating. The economics were unforgiving. Built for Central Ohio Coal Company at a reported cost exceeding $25 million in late 1960s dollars, Big Musky promised efficiency through size, fewer machines, fewer operators, unprecedented output. And for a moment, it worked. But standing beneath its boom, operators felt something else: inevitability. How does a company pioneer the limits of excavation and still vanish from the industry it helped define? By 1910, along the shores of Lake Erie in South Milwaukee, Wisconsin, Bucyrus Company was already synonymous with big iron. Founded decades earlier and later consolidated under Bucyrus Erie, the firm built its reputation on steam shovels that carved the Panama Canal and rail corridors across the Midwest. A 1915 Bucyrus catalog promised contractors machines built not for seasons, but for generations. That was not marketing, it was survival logic. Contractors bought once, repaired forever. The early factory floors smelled of coal smoke and cutting oil. Riveted frames, massive gears, everything visible, everything repairable. Engineers worked from drafting tables overlooking Lake Michigan, designing machines that would outlast their creators. Foundry workers poured steel that would move mountains. Reputation is a form of capital, and Bucyrus Erie had spent decades accumulating it. By the late 1940s, excavation faced a ceiling. Cable shovels were enormous, durable, and slow to adapt. Increasing bucket size meant exponential increases in structural stress, swing inertia, and maintenance downtime. Period trade journals noted a hard truth: productivity gains were flattening. You could build bigger, but not smarter. At job sites across Pennsylvania and West Virginia, contractors pushed machines to their mechanical limits. Boom cables frayed, gears stripped under load, cycle time stretched as machines grew heavier. Competitors like Marion Power Shovel and P&H faced the same problem. Everyone knew the plateau, but no one yet knew how to break it. Engineers at rival firms sketched designs that looked more like speculation than solution. The question was not whether someone would break through, it was who would risk everything to try. When everyone hits the same limit, the first one through pays the price. Bucyrus Erie's engineers leaned into electricity early, not hydraulics. By the 1950s, their walking draglines and stripping shovels were powered by massive, synchronous motors fed from external substations. An internal engineering memo from 1956 argued that electric power scaled better than diesel because it had fewer moving parts, infinite torque at low speed, and lower lifetime fuel costs. Operators trusted it. Dealers could service it. Utilities could feed it. At the South Milwaukee plant, test benches hummed with prototypes. Engineers calculated load factors and power curves late into winter nights. The company did not just build machines, it built systems. Electric drivetrains meant coordination with power companies, specialized substations, and cable management infrastructure. Every sale required negotiation beyond the machine itself. It was complex, capital-intensive, and audacious. When your solution works, you scale it, even when the scale starts to feel dangerous. In 1966, engineers finalized plans for a machine without precedent, a single-bucket stripping shovel designed exclusively for surface coal mining in Ohio's deep overburden. The designation was clinical, 4250W, where W stood for walking. The reality was biblical. Standing over 151 feet tall, weighing 13,500 tons, and powered by multiple electric motors generating over 13,800 horsepower, the machine would move earth at a scale no fleet could match. Design documents filled entire filing cabinets. Structural calculations required new computing methods. The boom span exceeded anything built for construction equipment. A Bucyrus brochure declared one machine, one operator, one solution, Project engineers knew the risk. Concentrating that much capability in a single unit meant concentrating all the vulnerability too. No backup, no redundancy, no retreat if the economics shifted. But Central Ohio coal needed overburden moved faster than any fleet could manage. Simplicity at extreme scale becomes fragility. Fabrication began in 1967, spread across multiple plants before final assembly at the job site near Cumberland, Ohio. No rail line could carry it whole. Every component arrived oversized, slow, and deliberate. Workers bolted steel plates thick as phone books. The boom alone weighed more than a loaded locomotive. Welders worked in shifts around the clock, their arc lights visible for miles across the Ohio countryside. The bucket, fabricated steel with replaceable teeth, held 220 cubic yards. Operators joked it could swallow houses. They were not wrong. Assembly required coordinating deliveries from Wisconsin, Pennsylvania, and subcontractors across the Midwest. Cranes lifted sections into place while engineers verified tolerances measured in fractions of inches. By late 1968, the frame stood complete, dominating the skyline like industrial architecture from another century. When a machine cannot be moved, the job site becomes permanent. By 1969, Big Musky took its first bite. The sound was not a roar, it was a deep electric hum, punctuated by the crack of stressed earth. Cycle times were astonishing. One pass replaced dozens of truck and shovel movements. Central Ohio coal reported dramatic reductions in labor per ton. The bucket descended, teeth biting overburden with controlled violence. Electric motors strained, then steadied. The swing mechanism rotated smoothly, dumping earth into waiting spoil piles. An operator later recalled in a dealer survey that you did not run it, you supervised it. Control levers required precision, not force. The cab vibrated with contained power. Below, the walking mechanism shifted the entire frame inches at a time, hydraulic feet planting and lifting in mechanical rhythm. When a machine becomes infrastructure, flexibility disappears. On paper, Big Musky delivered exactly what it promised. Cost per cubic yard dropped. Output surged. Industry journals called it the future of surface mining. Engineering publications ran detailed analyses of its drive systems and structural innovations. But the margins were thin. Downtime was catastrophic. When Big Musky stopped, everything stopped. A failed motor meant waiting for specialized parts from Wisconsin. A damaged boom section required fabrication lead times measured in weeks. No spare unit, no redundancy, no workaround. Central Ohio coal's production schedules hinged entirely on one machine's uptime. Maintenance crews worked preventatively, replacing components before failure, but the complexity meant constant vigilance. Small problems cascaded quickly. The efficiency gains vanished the moment something broke. Efficiency, without resilience, is a gamble disguised as math. By the early 1970s, competitors took notes, not by copying size, but by refining fleets. Companies such as Caterpillar, Marion, and P&H invested in multiple smaller units with higher uptime and better dealer support. If one machine broke down, 3 others continued working. Parts availability improved. Operators could be trained faster. Financing terms became more favorable for distributed equipment purchases. They let Bucyrus Erie prove the extreme, then sold moderation. Trade shows featured reliability, statistics, and life cycle cost analyses. Dealers emphasized serviceability over spectacle. Contractors began calculating total ownership costs, not just purchase price. The market was shifting towards systems thinking, overlapping capabilities, shared parts, inventories, and flexible deployment. Big Musky represented the opposite philosophy, ultimate specialization. Being first teaches others what not to do. At full stride, Big Musky was unbeatable. Its bucket cast shadows across acres. Its walking mechanism moved the machine inches at a time, shaking the ground like controlled earthquakes. No other shovel matched it. None tried. Operators developed rhythms measured in tons per hour, not cycles per minute. The machine operated around the clock when conditions allowed, illuminated by floodlights that turned night into industrial day. It wasn't just big, it was perfectly engineered for one job, one place, one economic assumption. Engineers visited from around the world to study its operation. Photographs appeared in technical journals and equipment catalogs. But perfection meant narrowness. The machine that could move more earth than any other could not adapt when the economics required something different. Perfection narrows options. In the 1970s, the energy market shifted. Environmental regulations tightened. Coal economics wobbled. Financing grew cautious. Strip mining faced increasing scrutiny from environmental advocates and regulators. Reclamation requirements added costs. Energy demand patterns changed. Meanwhile, Caterpillar expanded its dealer network, parts availability, and resale value. Contractors began choosing systems, not spectacles. Used equipment markets favored standardized models with interchangeable components. Banks preferred financing packages that distributed risk across multiple units. Bucyrus Erie's machines were still excellent. Engineers continued refining electric drive systems. Quality remained uncompromised, but excellence was not enough. The market rewarded companies that could deliver parts overnight, train operators quickly, and offer flexible financing. Scale advantages in manufacturing and distribution became decisive. Markets do not reward brilliance, they reward coverage. As smaller, modular machines improved, Big Musky became an outlier. Too big to replace, too specific to adapt, too expensive to replicate. Hydraulic excavators gained power and reliability. Diesel engines improved fuel efficiency. Wheel loaders offered mobility that walking draglines could not match. The very engineering that defined Big Musky now isolated it. No other mine wanted something so specialized. No contractor could justify the capital concentration. The machine continued working through the 1980s, moving overburden as designed, but it existed alone in its category. Engineers proposed scaled-down versions, but the economics never aligned. The breakthrough that seemed universal in 1969 proved site-specific by 1979. Once innovation becomes unique, it stops being contagious. Big Musky worked until 1991, when the mine closed, not because the machine failed, but because the economics did. Central Ohio coal exhausted the reserves that justified such extreme equipment. Bucyrus Erie, already weakened by competition and market shifts, would eventually dissolve through mergers and asset sales. The machine outlived the company's independence. In 1999, Big Musky was dismantled. Cutting torches separated boom sections that had operated as one for 30 years. The bucket was preserved and transported to Miners Memorial Park in southeastern Ohio, where it rests today. Tourists photograph it, surprised by the scale. The machine survived. The business model did not. Today, every modern electric mining shovel carries Big Musky's DNA, scale studies, stress modeling, and electric drive logic. But no one builds them that big anymore. The lessons were absorbed into incremental improvements across the industry. Marion and P&H developed their own large shovels, but none approached Big Musky's singular scale. The opening image returns, the bucket now silent, rusted, admired by tourists who never saw it move. The future Bucyrus Erie built arrived, just not with their name on it. If engineering alone decided survival, Big Musky would still be digging. A faded Bucyrus brochure, a control lever polished smooth by decades of gloves, a bucket resting in grass, proof that the future arrived and left its pioneers behind.